So hello everyone, my name is Quan Luu. So I'm currently a postdoc at Purdue University. Today I want to introduce our recent work on ManiFeel benchmarking and understanding visuotactile manipulation for policy learning. So yeah, there's recent progress in visual imitation learning or learning from demonstrations. And one of the enabler for this kind of visual-based learning policies is a benchmark that enables fair comparisons across the diversity of the tasks. And we also see recent progress in supervised visual tactile policy learnings, so where vision and tactile are integrated into the learning framework. However, in like the vision-based imitation learning, so actually there's lack of the benchmark for visual tactile policy learning that enable fair comparisons for the methods and improve the performance. So yeah, to address the gap, so in this study, so we introduced a benchmark platform for supervised visual tactile policy learning. So it covers a diversity of tasks like a USB insertion, power lock insertion, or some kind of tactile exploration or sorting. And it's also we also introduced several visually derated scenarios or challenging scenarios like manipulation inside closed container or manipulation in the dim light or dark environments. So here, for example, based on our benchmark here, so we want to answer the question. So does visual tactile policy always outperform vision-only policies? And the results show that so for visually challenging scenarios like tactile sorting in dim environments or tactile exploration in vision-occluded environments, yeah, of course, so visual tactile policy did improve the vision, have a higher performance to the vision-only policies. However, the tactile modality doesn't always have, like example, in the gear assembly here, we can see that so adding the tactile modality, yeah, in this reduce the performance compared to the vision only. So the results show that so we indeed require some advancements in the vision and tactile modality fusion strategies, as well as some smarter way to handle the multimodal policy learning. And here, so our framework also supports different kind of tactile representation learning. For example, here in this experiment, so with the same number of the tasks, so we evaluate the performance of the policy learning using diffusion policy with a different architecture of the tactile encoders, like the ResNet 18 training from the GRASH, or we use some pre-trained tactile representation like Unit T3 and AnyTouch. And the results show that so some tactile encoders with the pre-trained on the large scale data set of a tactile modality indeed improve some performance of the task. And lastly, so we also want to investigate so how does the tactile information affect various policy types. And in general here, so we evaluate with different policy algorithms like diffusion policy, flow matching, or equivariant DP. And in general, so the results show that tactile sensing improve the performance of all the policy. However, for the flow matching here, so actually the performance is not good enough. So it shows that so we need the careful design of the algorithms when the tactile sensing is introduced into the framework. And here we also use some point sorting experiments to evaluate our benchmark in the real-world experiments, like the bond sorting here. So the robot needs to recognize the ping pong ball and golf ball and move it to the target balls. And the results show that the vision and tactile so always outperform the vision, and even in the extremely challenging scenario like the dim light here. So the vision only policy performance derated a lot. However, the visual and tactile policy maintains the performance reasonably. And here we also show that so the vision and with the tactile complementary can enable some tactile reactive behavior of the visual tactile, so where the robots can respond and recover to some external disturbances, like when the ball rough is taken away. So on the left-hand side, the Visuotactile policy can recognize the ball is removed based on the touch sensing, and it can reposition, reach the ball, and then move it to a target position. On the other hand, on the right-hand side, the vision policy lacks the tactile sensing capability, and it's kind of failed to complete the task. And thank you for your listening. So if you are interested into our work, so please visit our website, and I'm happy to take any question in the poster session. Thank you very much.